and welcome to the Water Test Network's second international webinar, which focuses today on our innovation challenges, as well as a new service that we have to offer, environmental technology verification. The webinar is scheduled to last no more than an hour and a half today and is being recorded. So it will be made available via our website for you to listen to again, share with your networks, and for those who weren't able to join us today. The agenda for today is on the screen in front of you. So I will introduce the Water Test Network before handing over to my colleague, Charlotte Buchart, who will tell you a little bit more about the innovation challenge we have live at the moment around brine treatment technologies. You'll then hear from Jasper Strove from Backer Oilfield Supply, who is the problem owner for this challenge. We then have testimonials from two of our previous Innovation Challenge winners before we finish the presentations today by Gareth Newman to talk you through the new environmental technology verification that you can access through the Water Test Network. We'll end the webinar with a Q&A session so that you, the audience, can ask our speakers any of your questions. Please do put your questions in the chat box during the presentations, and we'll pick these up at the end. So my name is Ruth McNeil, and I am the Water Test Network Project Manager. The Water Test Network is a transnational collaboration, creating a network of testing facilities. It's our aim to address the key challenges faced by the water tech sector by supporting SMEs to develop, test, and verify their innovations so they can accelerate the time to market for these innovations to come into the water sector. We were allocated funding through the Interreg Northwest Europe programme under their innovation thematic priority, and we are 60% co-financed by the European Regional Development Fund for our total value project of €6.02 million. We have 7 project partners, 5 sub-partners, and 5 associated partners from 6 countries across Europe involved in the project. As with everyone, the last year or year and a half has caused us some delays, mostly around travel restrictions for SMEs to come to our testing facilities, but also some of our testing facilities did have to temporarily close while we put COVID protections in place. However, I'm happy to say that we've been up and running now again since July last year, but we did have some delay. So what we did is we approached the Secretariat and asked them and applied for a 1-year extension to the project, which was granted. So that the project's now coming to an end on the 6th of December 2022. Our application deadline for SMEs to access our support has also been extended, but will finish a little bit earlier in summer 2022, as that allows us to get our trials of SMEs through the project before the project end date of December 2022. The network provides access to 14 operational testing facilities across Northwest Europe, with access to a wide range of water types and applications. We have 1 in France, 1 in Germany, 2 in Belgium, 7 across the Netherlands, and 3 in Scotland. These facilities are accessible to SMEs across Europe, with a focus on those countries in Northwest Europe, which are highlighted on the map just now. As I said, there's a wide range of water types that you can access through our testing facilities. There's some listed there. So you've got hospital wastewater, sludge, tap water, rainwater, vegetable processing water. Really is a wide range of testing of water types that you can access at our facility. Our goal for the project is to speed up market uptake of innovative water technology by making it easier for SMEs to test and verify innovations to overcome that reluctance there tends to be in the water sector around unproven technologies. We do this through providing access to our transnational network of testing facilities, which enable SMEs to fine-tune and test technologies in a real setting so they can develop products that are market ready and linked to key sector needs. We do this through 2 key avenues of support. We have the first is innovation challenges. Now, They're problems experienced by water users for which we put out a call to SMEs to solve. Now, Charlotte is going to tell you a little bit more of our current challenge later on today. Our other avenue of support is actually our main avenue, which is our innovation support vouchers. This is an open application process, which was extended until summer 2022. And SMEs from across Northwest Europe can apply to receive funding to access our network of testing facilities. So the innovation support vouchers provide fully funded support packages tailored to the needs of SMEs, up to a maximum of €50,000 of total in-kind support. There are two types of innovation voucher that we give access to. So the first is access to a testing facility. Now this can be from a couple of days in a lab to several weeks in a real water treatment site. You can also use an innovation support voucher to access support with verification and validation to assist in market entry. So SMEs can get the likes of ISO with similar verification. And it now includes the environmental technology verification that Gareth will talk to you about later, which is a new service. So who can apply and when? As I've said, all SMEs across Northwest Europe can apply. So for our purposes, an SME is defined as an organisation with no more than 250 employees and a turnover of at most 50 million euros. You can apply at any point between now and summer 2022. The application process is relatively simple and we've tried to keep it that way. Your first point of contact is to contact one of our innovation chasers, so the one in your nearest area. And we have 8 innovation chasers across the water test network. I'll quickly introduce you to some of those. Some of them are on the webinar today. Okay, so you've got Charlotte from Belgium, Catherine from France, Yata from Germany, Liam from Ireland. You've got Geordie and Peter Jan from the Netherlands, Roger from Scotland, and Kerry, she's in Scotland, but she represents the rest of the UK as well. So it's a simple 2-step process for the application. The first is you submit a stage 1 application form. This is just 2 documents, the first of which is an SME or de minimis declaration. So you're basically just saying you are an SME and you've received no more than €200,000 of support in the past 3 years. The application form itself just asks some simple details about company information, what type of product it is, and what type of support you're looking for. Is it a test facility or is it support with validation and verification? The time frame for getting through your stage 1 is usually under a week, so it is not, it shouldn't take too long. Then you can, once that's approved by the innovation chaser, you move on to stage 2. Now, stage 2 is a bit more detailed, and you're supported in this by the innovation chaser that is responsible for the testing facility that you want to go to. Now, that innovation chaser will help you write the best stage 2 application form that you can. It is more detailed. We're asking for things like what TRL level you are, what testing plan you're looking at, and we can help with that. What's your target industry, your risks, your economic and wider impact. So we do ask you for a bit more information, but the innovation chaser is there to support you. That application then goes to an application review panel, which is made up of 3 of our water test network partners, and they review that application and either approve or reject it. Now, again, the time frame for that is getting your stage 2 through to approval is as fast as you want to make it. Just take the time to make a good application. But once the application is submitted, you can usually have it reviewed on average within 3 weeks. Once approved, you then go on. You then go on to our testing facilities. So this can happen in as little as 1.5 weeks. Again, it's up to the SME and the testing facility to work together to find the best way and timing for getting that on site. Okay, sorry, I've gone too far on that one. I'll go back one. So the project progress, what have we achieved so far? So To date, we have received 105 stage 1 applications from SMEs. 77 of those have been supported through to the stage 2, helped with looking at target industries and developing a testing plan. And we've approved 38 of those 77 so far. Though of those 38, we've taken 26 through to testing at the moment. So we've got 11 have completed their testing, and we've got 15 on site at the moment. Like I said, there is we have applications from across Europe, and the map in front of you just now just shows you just where all of our applications have come from. So we have had quite a few, and from across Europe. And we've had a number of different technologies that have come via the Water Test Network as well. There's a couple of pictures there of a few that have come onto our sites, but they've ranged from treatment solutions for recycling water for greenhouses, sludge treatment, sensor technologies, screening technologies. It really is a vast range of technologies that we've had. The last thing I want to talk about just now before I hand over to Charlotte is our long-term aim. So by the end of 2022, we hope to have supported about 90 technologies coming through the Water Test Network. But what's more is we hope to have established that us as a sustainable network of testing facilities that can continue to provide that innovation support to many others for many years to come. So this year, part of our focus is looking at what that business model for a sustainable network will look like after the Interreg funding comes to an end. So the partners are considering what our structure will look like and whether to extend our facilities to new sectors, new locations, and wider innovators. Okay, so that's all from me just now. I will hand over to Charlotte Buchart, who will take you through the innovation challenges.
Yes, good morning, everybody. I hope the sound is clear from my side. I will tell you something more about the innovation challenge on brine treatment technologies. Let me check if I can already move the slide. Yes, of course. So Ruth explained that there are two ways of getting support. You have on one hand the innovation support vouchers, which Ruth has already explained, but you also have the innovation challenge. So what we do is actually we define a problem which is encountered by end users in the water sector. It can be drinking water companies, utilities, industrial companies. So there is a problem, and we invite SMEs to come with an innovative solution. So, and by doing so, we hope that the end user might be potential clients of these SMEs, and as such that the SME can have market access. So during the lifetime of the project, we have the aim to launch 5 different innovation challenges, and to date we are at the stage of the 4th challenge. In the past, we have launched a challenge on sludge processing, on the removal of pharmaceuticals and PFAS, and now our brine treatment challenge is live. And later this year, we will launch a 5th challenge, but the topic has not yet been defined. So the story about the brines, I think most of you know it, but when we apply membrane filtration technologies such as ultrafiltration, nanofiltration, reverse osmosis, or electrodialysis, then we produce brines. So you have the filtrate and you have the concentrate. And to date, more and more companies want to invest in water reuse. So filtrate technologies are being applied more and more. So we are generating more and more brines. Today, these brines are either discharged, often after dilution, or disposed. And now also in Europe, we are more and more exploring the geothermal energy, and this is also associated with the production of brines, and these brines can still contain some valuable elements such as, for example, lithium. Now, the idea of this challenge is that we try to valorize brines. So we are looking for SMEs who have technology to do something with the brine so that it can have a further valorization instead of disposing it. So what we offer to the SME is we offer you brines from either a drinking water production center, an industrial wastewater treatment plant, or a geothermal site. And if you have an innovation which is at least at technology readiness level 4, which means that your technology has already been validated in the lab, or if the TRL level is higher, then you are welcome to apply for our challenge, and we will select a cost-effective and sustainable solution. So when you are the winner of our challenge, you will get access to a test site which has brines. You will get test support by means of, for example, an operator, electricity, analysis. And you also will get the opportunity to showcase your results to important stakeholders. This can be done through a webinar. Normally, you can also join us if COVID allows to join us on an international water-related fair. And we can also post news about your project results in our newsletter. Now, how is the application process? It's actually completely similar as the one for the regular innovation vouchers support. So you can first of all contact the innovation chaser in your area. Then you need to submit a stage 1 application form. And then you go to a stage 2 application form. So Ruth explained stage 1 is very basic. It's more administrative and explaining what your innovation is about. Stage 2 is a bit more in depth. It's about a 10-page document in which you convince us about your innovation, about the economic impact, about the environmental impact, and so on. And then in the end, we will select one winner. So if you get more application, only one company will get, let's say, the winning ticket to go to a test site, but we will redirect the others to the regular voucher system. So you can still come and test your technology, but you will not get, let's say, the access to an international water fair via the water test network. Now, what is the timeline? So this challenge has been launched in February this year, and it will remain open until the 5th of September, 12 p.m. And then already 1 week later, we will have the evaluation among the jury members. And then depending if you are ready or not with your technology, you can start from October on or a bit later. So that was my part about the innovation challenges. In case you have further questions, you can raise them at the end of the webinar. Thank you.
Thank you very much, Charlotte. And I do encourage anyone in the audience with questions around that innovation challenge, please do keep putting these in the chat. The next speaker is Jasper Strove from Bakker Oilfield Supply. Now they're the problem owner for the latest innovation challenge. So I'll hand over to Jasper now to tell us a little bit more about their problem owner's perspective for this challenge.
Thank you, Ruth. Thank you for the introduction. And also thank you for the opportunity to present our company in our innovation challenge of innovation problem. My name is Jasper Strove. I'm operations manager at Bakker Oilfield Supply. Next to me is Gerben Slomp. He is a team lead of our project and engineering department. And together we do about 90% of all the innovation projects within our company. Yes, Bakker Groep Koevoorden. We started in 1984. We are a family business. We have 3 companies in Koevoorden, 1 in Schonebeek, and we generally focus our business in Europe on the energy industry. And since the beginning of our company, we have a strong connection with NAM Shell, with the Schonebeek oil field, but also with the first Dutch gas well in Koevoorden. This is our organization chart. Bakker Groep Koevoorden is the holding company. Then we have the Bakker Koevoorden BV, which is storage and scrap metal. Then we have the Gebroeders Bakker Aanneming Koevoorden BV, that's a contracting company, and Schaves BV is a safety company with 3 departments, which are trading academy, safety consultancy, and a field crew, which includes riggers, rope access people, and rescue teams. And the 4th one is Bakker Oil Food Supply, where we both are active. And we do our business in rental, service, competent people, project management. So we try to give a total well service solutions to our clients. To introduce our company, we have a small video. I'm not sure if the sounds of the video is working, so I will explain a little bit what you see. You see our facility with the sound wall and the storage facility. No, I noticed that there's no audio, so sorry for that. This is one of our degas we use in the geothermal well testing. We've got a big outside storage facility where we store our rental equipment. Here you can see all the tubing and casing for all the wells we are drilling or we are assisting to. This is a small jaarknik, as we call it in Dutch, which we installed for the opening of our company in our new facility in 2013. This is our cleaning department, which cleans all the rental when it's going in and out. And this is some crossovers and also our rental storage facility, which I will tell you a little bit more later. This is our workshop where we do all our own testing of our rental, especially high pressure equipment up to 10,000 psi, 700 bars. So in the oil and gas industry, that's high pressure to use. In the geothermal industry, we see about approximately 100 bars. We do wall thickness measurements, calibration, and pressure testing of all the high pressure piping, and we do all we do in our own facility. Sorry for the sound. Here you see the general scope of Bakker Oil Food Supply. You can see all the bullet points in what we do. Here you see that we try to provide our clients a total well service solution. As you saw in the video, we have a rental fleet of over 3,000 different items. We have a very experienced engineering department and a competent field crew. With a competent system we set up ourselves. And because we try to give our clients the total well service solution, we also try to give our geothermal clients the total solution, and that's where the next innovation challenge of innovation problem is coming from. When the rig is done and the well is drilled, we get our equipment to the site and we we do a clean out or a performance test of the geothermal well, and during the test we produce about 5,000 cubes of geothermal water, and this produced water is a very high has a very high salinity and can contain hazardous elements such as small amounts of heavy metal and radioactive particles. Up until 2015, it was a common practice to transport the water by means of trucks and dispose it off in certain designated areas into the national water as wastewater. Wastewater, which is the department of the government, has indicated that disposal of this geothermal water under these conditions will be limited and maybe it will be banned in the near future. which is creating a waste disposal challenge. This new situation creates an uncertainty for our geothermal clients. That's why we started the study 3 years ago together with CEW to find alternative methods. CEW also introduced us to W2N. So we tried to find alternative methods of disposing this geothermal water flow and gaining more knowledge about the current disposal requirements in the process, but also to see if there are different techniques. Until now, the study has not led to a final solution. We found a possible working technique called, I look at my paper, mechanical vapor recompression, MVR, which we currently are working on with several companies, but we are facing some technical challenges, so we are working on that. But we like to ask you and the audience to think with us, see with us for an alternative method or alternative technique to process the geothermal water in such a manner that it not has to be treated as wastewater anymore, or at least to a minimum. So we don't have to use the trucks and we can dispose it perhaps on the sewer. We think this will have a positive environmental impact and hopefully also a cost reduction impact for the project. But we need you to find a solution for that. So this technique has to be mobile because we are doing the testing in all of Europe, and it's normally a test has a duration of about 2 weeks, and we have to be able to process 5,000 cubes of geothermal water within 25 days. Why in 25 days? Because when the first well is drilled, then it takes up approximately 25 days to drill up the second, and that's why we need that the 5,000 cubes that are stored in the bassins, you will see in a video later, has to be empty again. These 25 days includes the mobilization, rig up, rig down, etc., etc. This is very short our geothermal challenge, our innovation challenge. If you want some more detailed information or you have a solution, please contact me on my contact in the bottom. Now we have a small video of geothermal well test we perform, and you can see in the back the basins where the 5,000 cubes of geothermal water is stored. So, wrong button. Oh, yeah, there it is. It's a small video, and you see all the well test equipment, degasser in the back, some high pressure pumps, and in the back you see our flare with the flame, which is the gas we collect out of the geothermal water. And in the back you see the big basins with the 5,000 cubes of water which has to be processed. Thank you very much for your thank you very much, and hopefully somebody has a solution for us, and we would like to be in contact with you. Thank you very much.
Thank you very much, Jasper, for talking us through the challenge that your company is experiencing. So hopefully that gives some people on the call. You've laid down the gauntlet for them to come with hopefully a potential solution. So thank you very much for that. So our next speaker today is Steve Skill from Greenskill Environmental Limited. Steve won our second innovation challenge, which was around pharmaceutical removal. So I'll hand over to yourself, Steve. Thank you.
Thanks, Ruth, and good morning. I'm Steve Skill, Managing Director of Greenskill Environmental Technology, and I'd like to thank Scottish Water Horizons and the Water Test Network for the invitation to present our work today. So we develop processes that employ microalgae to recover resources from wastewater. And we grow the microalgae in novel photobioreactors. These are devices to propagate algae. And of course, algae being photosynthetic, they require light for growth. And of course, photobioreactors effectively provide a device to get light into the algae most effectively. And the systems we've designed, we can scale these up to megaliter volumes. So here we go. So back in 2019, we were successful in winning our first innovation challenge. This was to demonstrate phosphorus removal from sewage. And here you can see a photo of the Wastewater Treatment Development Centre at Bowness, operated by Scottish Water Horizons. It's an absolutely superb facility. Sorry. And you can see that sort of cylindrical device in the center of the picture there. That is our small pilot scale photobioreactor. And along the back wall of this facility, you can see the 3 pipes there. They can deliver either raw sewage or post-secondary treated sewage or sludge. So it's a marvelous facility, and we can just plug into these lines and then use those to feed then into our reactors. And so in this first trial, we took raw sewage, post-primary settled sewage, and we propagated an algae called Chlamydomonas. This is in collaboration with Anya Escudero at Glasgow Caledonian University. And we were able to, for the first time, demonstrate that algae could treat raw sewage. And this has never actually been done before. Normally, algae are capable of tertiary treatment of secondary treated sewage, but not. They haven't been able to. Nobody's demonstrated secondary and tertiary treatment using microalgae. So it's a bit of a first for us, and it was great to be able to demonstrate this at Bowness. For that trial, the James Hutton Institute and Gareth's team carried out the accredited analyses, and we proved that we could reduce the phosphorus in the final discharge to less than 0.2 milligrams a litre. The hydraulic retention time we achieved was 1.5 days, but we believe that if the trials were extended and you get a certain amount of microevolution going on with the microorganisms, and we believe that we can get that down to 12 hours, and that's our target for the future. What is fascinating is that the final discharge wastewater is crystal clear, but had a really lovely sweet citrus smell. It's very pleasant to smell, unlike the input raw sewage. Now, what's interesting about our process is that we don't use aeration, or we don't use any forced aeration in our process. So we haven't got any gas emissions at all from our process. So what that means is that effectively, so if we're looking at, if we look at conventional sewage treatment, I can see the raw sewage coming in from the left, going through primary settling, and then the overflow from the settling then runs into the activated sludge process. And of course, forced aeration results in the release of a number of greenhouse gases, including CO2 from the biogenic degradation of the BOD. Methane is often present due to formation in the sewage pipes. Dinitrogen oxide, of course, is a potent greenhouse gas. And of course, there are fluorine-containing gases and other volatiles, and potentially other pathogenic agents which are present in the aerosols. And of course, activated sludge doesn't really treat the wastewater that effectively. We're still left with nitrogen, phosphorus, and microplastics, and pharmaceuticals, endocrine disruptors, and perfluorinated compounds in the final wastewater. And it's interesting, actually, that the sewage treatment industry is thought, opinions vary on this because it depends how you do the calculations on greenhouse gas emissions, but it's thought that the sewage treatment industry emits between 3 and 6% of total greenhouse gas emissions globally. So what we're proposing, or what we're developing, is a negative emission sewage treatment process whereby we can take the raw sewage, undergo primary treatment as usual, primary settling or mechanical filtration, and then feed that post-primary wastewater directly into our photobioreactors, where the algae perform secondary, tertiary, and quaternary treatments in a single stage. We can use the unique properties of our photobioreactors also to treat the biogas from digestion of primary sludge. Stoichiometrically, sewage doesn't contain enough carbon for the algae that the algae require to completely assimilate all the nitrogen and phosphorus. So we need to add additional carbon. So effectively having a carbon negative process. So in treating the biogas, we can then effectively upgrade that, and then we can also treat the exhaust and recover any NOx from the combustion process in a second. It's directly coupled photobioreactor with the first. So, and at the end of the day, what we're trying to achieve is a complete treatment of the wastewater. So that's removal of pharmaceuticals, nutrients, and other emerging compounds, and without any gas emissions whatsoever. So this is what we're trying to achieve. And of course, the harvested algae could then be used as a soil conditioner, fertilizer, and plant growth promoter. This is a photograph of our reactor, which we've actually now reinstalled back in at Bowness. We were successful in winning the Water Test Network Pharmaceutical Challenge, and this is currently underway at the moment. And so what we're doing to demonstrate the efficacy of pharmaceutical removal is essentially dosing a suite of pharmaceuticals and into the bioreactor, and then TZW are going to be looking at the analysis. I'll talk a little bit more about that shortly. So that's it's a photobioreactor which relies on LEDs and lasers to provide the illumination for the algae, and it's self-cleaning, and it's a very simple device, and it's very low maintenance, and it just churns away and does its job. So this diagram just depicts the overall process of what's going on. So we've got the raw post-primary settled sewage being dosed in, and we'll be dosing in a pharmaceutical cocktail, and we'll take samples immediately prior to dosing this sort of pharma raw sewage mixing into the reactor. And then, of course, at the back end, we'll be taking samples of the treated effluent. It's a simple process, and the only thing we need to really inject into the process is carbon dioxide, CO2. And this is on demand. And we currently use tangential flow filtration to recover the microalgae and, of course, produce the final treated effluent. There are other methods of doing this, and this tangential flow filtration is the simplest in terms of process and control, but we can use others. So into the reactor, we're going to be dosing this cocktail of pharmaceuticals, which is kindly put together by Dr. Beate Hamsch at TZW, who's going to be doing the analyses. And you can see we've got quite a broad range of different pharmaceuticals, including hormones and antibiotics, which are very commonly found in sewage, and can, of course, be problematic when released into the aquatic environment. So that is our challenge. And as I say, the trials are currently underway. We're just acclimatizing the algae at the moment in Bowness. And as I mentioned earlier, this is a design of one of our larger photobioreactor modules. This is a 40 cubic meter system. We can scale up to well beyond 100 cubic meters, and we're looking forward to really getting stuck into the trials at Bowness. Incidentally, the team, the facilities, and the overall environment to work in at Bowness, at the Water Test Centre, is second to none. I would highly recommend it to anybody who's interested in performing such trials. So thanks again, you guys and the team at Bowness, and that's our piece. So thank you.
Thank you very much, Steve. It was interesting to hear about you. I know we have had a question about your technology, so we'll pick that up in the Q&A session at the end. So that's great. And fantastic feedback around the water test network and the support you're getting through the testing facility there. Okay, so our next speaker is Hans Belial. He's from SODECON. SODECON applied for a third innovation challenge, which was around PFAS removal. So I'll hand over to Hans now.
Thank you, Ruth. My name is Hans Belial. I'm the business director of SODECON. We are a soil and groundwater remediation company. We're specialized in solutions for complex environmental problems. And in that, we also look for innovative solutions for contaminants like the PFAS. We came into contact with the PFAS in our soil and groundwater area. And then we had an idea to treat PFAS from wastewater. And that's what we have made a proposal for in the PFAS challenge. To give you an idea about PFAS, it's a group of fluorinated carbohydrates. It contains more than 1,000 substances. Lately, there's an increased awareness on PFAS. For example, yesterday there was a debate in the parliament in Belgium on the PFAS problem. So it's really on the radar of even politics at the moment. Some of the characteristics of these compounds: they are toxic in low concentrations. They are very resistant to degradation. They can only be destroyed at high temperatures, incineration of temperatures higher than 1,400 degrees. It's very difficult to remove them from water because of their limited sorption capacity on activated carbon. So that's why they're currently not very cost-effective treatment technologies available. What we have proposed is to test different adsorption media with high sorption capacity for PFAS, 5 to 10 times higher than activated carbon, to increase the efficiency of PFAS removal from industrial wastewater, and to make PFAS removal in that way more cost-effective. Before the Water Test Network Challenge, we had performed TRL4 tests on our own on the deionized water, and we could identify 4 adsorption media that were very promising to do further testing. And then we made a proposal for the Water Test Network to perform batch and column tests with real wastewater to test the adsorption media in a better or in a real environment. We cooperate with the Flemish research facility VITO, and we see the following added value of the water test network and VITO is that we can cooperate with a knowledge partner that brings in experience that we don't have. For example, they've already had a lot of experience with batch and column testing for other types of water, and this really helps us getting forward with our technology. For us, it accelerates the product development as we have a budget available to do our testing. And it's also a real good advantage to have an independent validation of the technology by VITO, which increases the credibility of our product. For example, it makes it easier to get access to wastewater from companies if we work together with an independent research facility. And also to get our technology to clients, the increased credibility is also very interesting for us. To give you an idea about the project timeline, in September last year, we went through a stage 1 application. In October, the stage 2 application, and in November, we had the project granted. Then directly after that, we started with the preparation, and in April, we started with the batch testing. And we are currently waiting for the first results of the batch testing. And then we can proceed to the column testing, which should be in the second half of this year. So you can see already here that, that I think is one of the main advantages is that there is a very short lead time before we can get started with our project. So our experience with the water test network so far is that there's a limited administrative burden. The stage 1, stage 2 application forms were they were not so heavy, and it was rather it was not so difficult to fill in all the necessary forms. Like I said, there's a short lead time. We could start actually quite fast with our project, and we're also very pleased with the guidance of the water test network during the procedure and the help they provided with filling in all the documents in the preparation phase. So that's my part on on our proposal. If you want any information on our PFAS solution, you can contact me at the email address you can find here.
That's fantastic. Thank you very much, Hans. It was interesting to hear a bit more about your technology, and great to hear that you've found the experience so far with Water Test Network useful and relatively straightforward. That's what we like to hear. It's not an administrative burden. I like that line. I might have to steal it for the next webinar. So our saving the best to last, of course, we've got Gareth Newman from the James Hutton Limited, who is going to present our new service, which is environmental technology verification. So Gareth, I'll hand over to you.
Thank you very much, Ruth. I'm not sure I quite expected that save the best to last. I thought you were going to say last but not least, so I was prepared for that. My name is Gareth Newman. I work for James Hutton Limited, and I am the service delivery manager for said company. And I'm also the technical manager for the quality management systems that we have. Okay, so what is environmental technology verification? Well, its objective is to provide credible, reliable, and independent verification of the performance of environmental technology, which either results in environmental added value or measured parameters that indicate an environmental impact. Such technologies have an increasingly important role in environmental challenges and achieving sustainable development. It is applicable to environmental technologies where innovation or performance cannot be fully assessed by existing standards. And by providing objective evidence, ETV provides independent and impartial confirmation of the performance based on reliable, accredited test data. So ETV in a global context, it was established in the US in 1995 and was later introduced into other countries, including Canada and South Korea in 1997. The Philippines in 2007, Japan 2008, and in Europe in 2011. When the number of jurisdictions offering ETV started to expand, there became a desire to coordinate activities. The International Working Group was created, and the performance of many environmental technologies has since been verified in these countries, with ETV protocols developed at national and international standards. In November 2016, ISO 14034 was created, and it was approved by the CEN in January of 2018. So why would you want to verify to an international standard? An ISO standard is recognized in an international market. It reduces duplication where repetitive testing is required to prove a point. It encourages and enhances the use of innovative technology responding to global environmental challenges such as climate change. It encourages collaboration in development of future technologies. It gains the trust of regulators and investors where new technologies often meet with mistrust. It can reduce the cost of demonstrations. It can assist in the performance of the new technologies, which is often challenging for small and medium-sized enterprises. So the context of ISO 14034, environmental issues are more of a global problem, and regulatory guidelines and tools, including environmental technologies, are the potential solutions. ISO 14034 works in parallel with the other 14,000 series to ensure that environmental issues are proactively managed by stakeholders. So scope and key definitions. Well, the scope principles specifies principles that procedures, and requirements for environmental technology verification. What makes environmental technology? Well, it's technology that either results in an environmental added value or measures parameters that are an environmental impact. So environmental added value and environmental impact are defined on the screen there. The key principles of ISO 14034, well, it takes a factual approach based on relevant evidence. Its sustainability is supported by providing credible information. ETV allows flexibility in the performance through dialogue between the applicant, verifier, and other interested parties. And it is based on 17025 accredited test data to the greatest extent possible it is, and methods that are fully disclosed. The reports are clear, complete, and objective, and useful to interested parties. So what kind of key questions does ETV answer? Does the product conform to regulations? Does the whole life cost provide economic benefit? The standard is a 14,000 series, so it'll examine that. Does the innovation deal with a problem? The claim will be made to tackle a problem against which evidence and robust test data must support. Is the evidence suitable to site-specific conditions? This can be tested against appropriate site for which specific test conditions will be set. Is there a market for the product? It has to be clearly identified and research carried out as to what the actual use and the application is going to be. Does it have stakeholder support? its interested parties are documented and their needs addressed. Because it is an international standard, this will build confidence to the answers and the questions that are addressed in the report and satisfy the accreditation body. So the ETV process is a fairly linear process. So the applications come in, there's then a pre-verification stage, and then a verification plan is made as to what else needs to be addressed. The test data is assessed, and whether there's more testing data required, that loops round until there's sufficient test data. The verification of the performance is then made, and that is then creates a report and a statement. The report, which is available to the applicant, and the statement goes public. So, working through the standard, the main requirements of the 14034 procedures, the application, this requires obviously the name and address, the description of the technology, which includes a unique identifier, a commercial name, identification number or version number, the purpose of that technology, the type of material it is intended for, measurable property and how it is affected, information sufficient to understand the operation, the readiness for market. We've heard about TRL levels already today, so it needs to be TRL 4 or higher. Relevant alternatives for the technology that's being applied, including performance factors of those and the environmental impacts. The performance claim, including a proposed set of performance parameters and their numerical values to be verified, existing test data, relevant legal requirements, supporting information such as health and safety, operating requirements, maintenance, servicing, etc. So the pre-verification stage, the performance has to be expressed by means of a performance parameters in consultation with the applicant prior to the establishment of the verification plan. At a minimum, they need to be relevant and sufficient for the verification of the performance and its environmental added value. They need to meet the needs of interested parties. They can be quantitatively verified by testing the numerical values and verified under set operating conditions. Existing verification and technical references are available. The verification plan must include a unique identification for the verification and the date of issue, and a list of performance parameters and numerical values and descriptions of how they will be verified. All data must be accredited, as already stated, to 17025 to be accepted, and must be relevant to the performance that is being verified and shall be assessed against the performance verification plan. Any requirement for additional data will be communicated to the applicant. The results of the assessment shall be confirmed in the performance of the technology achieved under the same conditions, constraints and limitations of those specified for the generation of the test data to be verified. The main requirements for the ISO 14034 procedures also include the reporting, which must contain all relevant details as detailed there on the screen. The report is then submitted to the applicant for review and comment, which may be incorporated as deemed appropriate. There will be a verification statement that will ultimately be made publicly available on a website hosted by the verifier, obviously subject to the approval of the applicant. So what type of technologies does ETV apply to? Types of technologies include new technologies that have environmental benefit over the current technologies, where technology goes beyond the regulations and standards. In other words, it performs better than need, and there is a need for differentiation. The scope of the technologies include water monitoring technologies, water treatment technologies, materials, wastes and resources, energy technologies, in particular renewables. Apologies, that slide seems to have disintegrated a little bit. Apologies for that. ETV does have its limitations. It is a statement. A statement is issued and made publicly available. This is not a certificate. There is no predefined criteria. This is set during the application stage by the applicant. So there is no pass-fail judgment on the technology. But it must justify how it meets the application required. ETV is not a substitute to existing regulations or voluntary systems. ETV will not substitute the actual testing of a new technology, but will review the test results in order to assess the veracity of the performance claim. ETV is concerned with the technology and design, the design of a technology, not with the production series of industrial products. So ETV can help when the manufacturer is new to the market. The technology is a niche solution. There are many similar technologies available to distinguish a technology among the competitors. Technology performs better than standard, but certification does not demonstrate this. And there is no standard to confirm the performance, or there are different standards. So to summarize, environmental technologies are now front and center in dealing with climate change and environmental priorities. ETV provides objective and reliable evidence on the performance of the technologies, and ISO 14034 will ensure the standardization of the process is acknowledged worldwide. ISO 14034 is a tool that could be used by stakeholders in combination with other standards, regulations, and codes of practice, etc. Okay, thank you very much for everybody. That's me, and my contact details are on the screen should anybody wish to get in touch.
That's great. Thank you very much, Gareth. It's interesting to hear a bit more detail around that new service that you can access now through the Water Test Network. So thank you very much. Okay, so that's the end of our presentations for today. So we are entering the Q&A session. So can I ask all of our speakers to please put on their cameras and their microphones, and we will see what questions we have coming in. So please, if I can ask the audience, please do pop your questions in the chat, which is just at the bottom, if you've got any. So, okay, so I've got a question in here, Steve, that came in during your presentation about your technology. And the question here is, how robust and adaptive is the algae process? Just because of the differing wastewater and the changes in the wastewater over time that you get at each location. And a comment that it was a very interesting presentation as well. So if you could answer that.
Yeah, thanks for the question. I think we established our first algae-based wastewater treatment facility at Severn Trent in the early 90s, looking at tertiary treatment. And way back then, we found that the process was robust and we could maintain the system indefinitely. And that still stands. And this is what we found in our work at Bowness. The algae do need time to adapt to a new wastewater. If they're introduced to a new wastewater, the algae adapts. The algae don't grow on their own. They grow in a consortium along with bacteria and aquatic fungi. And this consortium does take time to evolve effectively. And it depends on the type of wastewater, but it can range from a couple of weeks up to a month for this acclimatization to occur. But once acclimatized, the bugs remain very robust. And it was interesting back in the early 90s when we had a tertiary treatment system running at Stoke Bardolph in Nottingham, and there was a slug of toxic discharge into the Stoke Bardolph sewage treatment plant, and it completely knocked out the activated sludge. And of course, that then came through to our algae process, and the algae turned brown for a day, and then recovered in 2 days, and we're back to normal. Whereas the activated sludge took at least a week and nearly 2 weeks to actually fully recover. It was a nasty slug from a particularly large engineering facility based in Nottingham. I won't mention any names, but it was. So basically, from our experience, we found that the algae processes are very robust once you allow them to acclimatize.
That's
so
great.
I hope that answers your question.
Christian, yes, thank you. Thanks very much for that one, Steve. Hopefully that did answer your question, Christian. We've had another question come in for you, Steve. You're a popular man today. Just asking, how did you find the overall water test network application process? And sort of from initial request all the way to arriving at the centre? I know you were saying you had good things to say about the team at Bo'ness, but anything about the application process itself?
Yeah, the application process was very straightforward, and it was very, very clear. And at the time we were dealing with the innovation chaser, and it was very straightforward, and we found the process really quite easy. And yes, I thought the design, it was actually quite, unlike other application processes, it was relatively straightforward and involved, rather than a lot of emails going back and forth, it was a lot of face-to-face discussion, which made the whole process a lot simpler and a lot more human. And of course, in doing so, we could iron out any issues face-to-face. So it was very painless and very efficient from our perspective.
Perfect, thank you. It's very good to hear. Hopefully others in the application process have found the same thing. So thanks, Steve. A couple of other questions come in more generally around the project itself. So what happens if the project is budgeted to be above €50,000 for funding? So what happens with that is the top limit of the funding, and during the application review process, we do look at the funding that's being requested and seeing whether or not it ties in with the testing plan and what you're wanting to do. But if the project is more than that, there can be discussions about whether or not we support aspects of the testing plan. We maybe do, we just support the trial and not necessarily maybe any certification, or vice versa. So it's always worth having a discussion with your innovation chaser about that, and they will work with you around the funding as well. And then we've got another one about what the key success factors for the project so far. So I might pass this over to you, Charlotte, just to, from your experience of the project so far, what do you think our success factors have been?
Well, I think it has been said by the two testimonials. We have a very, let's say not easy, but a simple method to apply for a voucher. We don't ask 70 pages of motivation, of impact and valorization cost and so on. So I think it's a good way of applying, and the innovation chasers are close to the water business, so they can help you, they can be critical, ask you some questions. So I think it helps an SME to reach his goal and to work in an efficient way.
That's fantastic. Thanks, Charlotte. Absolutely agree on that. From what I've seen as an overview for the project, we've had some really interesting technologies coming through, and what we have found is because of the way that the test facilities work, there's a lot of knowledge sharing as well, both between the water test network partners, the SMEs, and amongst other SMEs that are maybe on site at the same time, and they've got similar technologies or technologies that can complement each other. So there's a lot of knowledge sharing that's going on, which is a bit of an added benefit I personally didn't expect when we first launched the project. Okay, there's another question here about how large do you think the market is for brine remediation? I might put that to Jasper, if I can, as in your opinion, how large do you think the market is around brine remediation, especially around the geothermal side of things, from you?
I don't have a specific number, but we think that it will be a problem for all the geothermal operators in the future. So that could be a pretty big market.
Yeah,
So
a
if we
lot
see
of
that,
opportunity.
yeah, we think that there will be between 5 and 10 projects per year. So that means 10 to 20 wells. So that's 50,000 to 100,000 cubes of water to process. That's quite a lot.
Yeah, and that's just from yourself. So I can just imagine what
Exactly. Yeah.
what we have elsewhere. So
It's only in the geothermal side, yeah.
A good subject for this challenge, maybe. Now, have I got any other questions coming in at the moment? I don't think so, not so far. What I will do is I will ask, just check with the speakers if you have anything else you would like to add. At this point in time, please take yourself off mute and say something now before I close. So Steve, sorry, yes, go ahead.
Yeah, I've actually got a question for Hans, and you mentioned heavy metals and radionuclides. Are they the only key target contaminants in the brine water? In the past, I asked this because in the past we've conducted trials on brine water from nitrate removal, ion exchange, and I was wondering if there are any other, if there were nitrogen or phosphorus or other contaminants in the brine water. Are the targets for removal just the heavy metals and the radionuclides? Yeah.
Is that a question for me or for Hans?
For Hans. Sorry, Jasper. Sorry.
Sorry. Okay. That's a difficult part of the innovation problem, because the contamination in the brine water is not always the same, because we have to deal with the different wells, so we have different contamination. So that's one of the difficult things in this problem, and that's why we are facing some technical problems. So yeah, the contamination can be anything. That's the point of view. That's also the difficulty.
Okay. All right, thank you.
Okay, if there's nothing else from our speakers or our audience today, all that's left for me to do is to close this webinar and thank all of our speakers today for taking the time to participate. It's been really interesting to hear about the innovation challenges, our innovators' experiences around the water test network, and to hear more about that new service, the environmental technology verification. So thank you very much to all the speakers. And a special thank you to Jelma Hobma from Water Alliance, who has been diligently working behind the scenes to make sure that this actually worked. My IT skills are not up to it. So well done, Jelma, and thank you very much for all your organization for this. And thank you to all the attendees for taking the time to join us today. Hopefully we will be speaking to some of you about innovation support, answering one of our challenges, or environmental technology verification. So thank you all once again, and I hope you have a great rest of the week.